Okay, hello everybody and welcome back. So here we do renewable energy, which really I should have called alternative energy, which is not the same as renewable, right? Nuclear would not be considered renewable energy. Why? Because it uses a finite resource, right? It has to be mined out of the ground and there is a limited amount of it. Unlike wind and sunshine, which there's basically an unlimited amount of it. Okay, for the first two, right, nuclear and wind, they work the same way as other ways of generating electricity we have looked at, all right? In the end, you spin a wheel to generate electricity, right? Solar, as we'll see, is a little bit different, a little bit special, but our discussion of electricity in the previous section is needed to be able to understand what is going on with solar. It's just stuff you gotta know. Okay, so we have some sort of really big atom, right? So carbon, right, it would be kind of small. Hydrogen is just like a single dot. Here we've got some massive unstable atom, right? And it's just waiting to explode and throw stuff off of it, right? And it turns out, right, if you bombard that, right, you fire a neutron at it, right, you can hit it and it will split into two smaller atoms, right? And as it does that, it releases energy and neutrons, right? And those neutrons go off and hit other radioactive things that are just waiting to be exploded, right? And then each one of these produces 3 more neutrons, which go on to explode others. Okay, so this is a chain reaction, right? Unlike with fusion in the sun, where we fuse small atoms together to make big ones, here we're doing the opposite, right? We're splitting them apart, right? This is nuclear fission, which is what takes place in a nuclear power plant. So what's happening here, right, is essentially you have a whole bunch of enriched radioactive stuff, right? And somebody gets the reaction started, hits it with a neutron, and that reaction continues, right? And it generates a ton of energy as a result, which does what? It generates a whole bunch of steam at a super high pressure, which spins a wheel to generate electricity, right? Which gets stepped up to a super high voltage. Okay, and we're off to the races and comes to us, right? This is generating an enormous amount of power, right? And it needs a steady flow of water to help cool it and to make sure that it does not overheat, right? Because it releases so much energy, you've got to be able to take the heat away, right? So before, when we talked about things like Chernobyl, Fukushima, or 3 Mile Island, the problem in those cases is that you have what is called a meltdown, where this stops getting cooled and the chain reaction spins out of control, essentially. Awesome. That is nuclear power. We have a nuclear power plant near us that generates something like a quarter of the electricity that you probably use, depending on your provider, right? So it is out here west of all of us, right? So Scottsdale, CC is like right here, and this is where I am, and here's downtown. This is the Palo Verde nuclear plant. Looks like this. It's really like 3 separate nuclear stations that are stapled together into one, and you may not realize, it is the largest single power plant in the entire United States is our Palo Verde nuclear plant, which is pretty great. Like, this is a clean energy resource for us to use, right? So when I talked about renewables as a percentage of U.S. energy overall, right, and that nuclear was like a tiny fraction of that tiny fraction, well, we're actually doing a lot better than that here in the valley, right? Our energy mix, which we get to in the lab, right, is a lot better than 13% renewables. And it's part of the reason why, combined with solar assets, that people are moving out here and why the economy is exploding, right? It uses treated sewage water, right? So this is water reuse, and we need tons of water to be able to fuel this thing from nearby cities, right? Built, what, I guess that would be 35 years ago, something like that. Generates enough power for 4 million people, which is great, right? So that's like half the number of people in the entire state of Arizona. Now, it does send some of its power off to California. I know. It should go to us. This is a huge asset, right, for us to be able to have, but it's also a risk, right? And famously, there have been times like in 2003 where it was even a suspected target for terrorist activity. So it makes this area, along with the semiconductor chip plant, really valuable strategically. Like, this is an important place for national security to the entire country, but also a target. And if you were a terrorist, right, and you were trying to do a ton of damage, blowing up this nuclear plant would be really bad because it's not that far from people, right? Should that be something that you're worried about late at night? No. You should be worried about things that you know are a problem, and I'll put it that way. Okay. Is nuclear energy renewable? And the answer is no, right? It requires this radioactive stuff out of the ground, radioactive as in spewing off smaller atoms and energy all the time, but it is much lower emitting than fossil fuels, right? And we'll crunch the numbers on this when we do the lab, but even factoring for all those construction costs and the concrete and the fossil fuels that are emitted as part of, mining those materials out of the ground and the steel and constructing them, it still ends up being way better than fossil fuels for the environment, even when all of that stuff is considered, right? Is it clean? Yes. Renewable? No. It also produces radioactive waste products that don't decay on the scale of a human lifetime, right? Nothing of value is buried here. I'll put that in a note. Is it a good idea? What's complicated with this is the timetable first, the upfront cost second, right? And the difficulty of cost overruns. So it takes years to decades to actually get these things online, right? In which time things can change. You can also have really complicated payoffs, right, or damages related to it. So essentially, nuclear power plants are subject to extreme outcomes, right? Not on a systemic scale, the way that infectious disease or war or climate change is, but they are subject to extreme events on a local scale and can compound the effects of other disasters like with Fukushima. So the answer to whether it is a good idea, I'm going to say, is on a case-by-case basis. It is yes, generally speaking, but no in the specifics, and that's as far as we can get. Next thing is wind, right? So why does wind even happen? Well, we're going to do the fast-forward version of this a little bit. Okay, so you've got the Earth, right, and you can picture in your mind, is it spinning like this, right? Like somebody took a basketball and did this with it, right? And because the Earth is spinning like this, and it's got this atmosphere of gas around it, those of us sitting on the surface, it feels like the wind is blowing, right? Because the Earth is spinning while the atmosphere above it is remaining stationary, and you end up feeling that as wind, right? In addition, right, the sun does not heat the atmosphere evenly, right? A ton of direct sunlight strikes the equator, gets it really hot, right? But less sunlight strikes the other parts. And when you have, masses of cold air and warm air in different places, the heat is going to travel from the hot place to the colder place, just like we saw with our heat lab, right? And that hot cup of coffee. And that's going to cause the air masses to move around as a result. And then finally, Earth's surface is not perfectly flat. You got mountains, valleys, all this other stuff that shapes the wind, right? And channels it and determines where it can go. Here, right, wind comes in, right? These are at an angle, and it causes these wind turbines to spin, right? Sort of like how an airplane can generate lift, right? Except in this case, this thing is stationary and the wind is moving, right? And inside of each one of these, guess what? The turbine itself, right, spins a wheel which generates electricity, sends it off to power lines to get stepped up and then distributed to consumers, right? Wind energy, broadly speaking, is exploding in the United States, onshore and offshore. There are environmental impacts related to bird deaths. However, when compensating for the fact that it's being used to generate electricity, which people need compared to fossil fuels, it just ends up being strongly in the favor of the wind farm, despite those trade-offs, right? Wind is not equally applicable everywhere, right? Some places are much more able to generate wind than others, right? We'll talk about the Great Plains specifically. So notice, right, these blues and purples and reds, right, all concentrated in the flatter Great Plains states, really good for generating wind, right? These are average wind speeds in meters per second, which, as you can see, are extremely high. And as a fun fact, despite the fact that Chicago has the reputation for being the windy city, average winds in Dallas are actually higher. So what's that about? Okay. Notice, right, these two maps, right? This is the place where we have high speed of winds, and this is where we have wind turbines actually getting built, right? It is kind of the same map between those two. Why is this place so great for building these wind turbines? You got no mountains here, right? There are essentially no obstacles between here and Dallas and the North Pole. Ask me how I know that, right? No bodies of water, right, which could stabilize temperatures, right? There's no stabilizing force in terms of the temperature, so temperature changes rapidly. So you get really crazy winds back and forth as a result, right? And we are in the middle of the continent, so there's no stabilizing forces from the oceans either. You put those three together and you get a great place for wind farms. Awesome. Last thing is solar. So we're going to do this in 2 steps. So this is kind of the zoomed out version, and then we'll zoom in a little bit, right? So the sun is putting off these things called photons. Before we said that light was a wave. Now we're saying that light is a bunch of particles called photons. Which one is true? The answer is both, and nobody understands why. Those photons, which are little light particles, which are also waves, come in, hit the solar panels, and convert it into DC, which now we know what that is, direct current, right? You have to go through this thing called an inverter to step it up, right, into alternating current AC, which is much better to travel and then powers the stuff in your home, right? If there is extra electricity generated this way, it can be stored in batteries, right? Or, you know, if you are a residential person, right? If you are just a homeowner and your house generates a lot of electricity because of solar panels, you can actually sell it back to the electricity companies and make money that way. So that's kind of nice. In a little bit more detail, right? So light is made out of tiny particles called photons, which are also waves, and nobody understands it, I promise. Those particles come in, hits these things, the photovoltaic cells, right? And as it hits the things in the solar panel, it knocks electrons loose at a high energy, right? Now that they are free to move, right, we have a flow of electrons, which is current, right? It generates electricity, right? You have some sort of conductor at the end, right, which sucks all the electricity out of it and gives it a pathway to move to the inverter, which takes it from DC, which is what is generated this way, right? This is a direct current. It's not alternating current coming from the sun. To the inverter, to something that steps the voltage way up and then goes off to be residential power, right? What places are going to be the best for doing solar? Well, this is another reason why the economy here is doing so well, right? Is because Arizona, in particular, has a ton of land open for development of this. It's not, you know, all developed and crowded the way that California is, right? All of this part of the American Southwest has tremendous potential for solar power. It is slowly ramping up, right? So wind power all through here, right? We notice it's not applicable everywhere equally. Solar power is especially applicable here, not applicable to the whole country equally. Something to keep in mind that these only work really in certain locations. As far as Arizona as a whole, right? You can actually notice that we're not putting in as much solar as maybe we could. The reasons behind that are complicated, but we're getting there, essentially. Bit by bit, Arizona is installing more solar and a large part of driving the economy here. Big questions, right? Breakthroughs, right? So James Watt and the steam engine, right? The creation of the turbine, the transmission of electricity, Henry Ford and the car, right? All of those things that lead to transformations in the way that human beings use energy. Those different types of fossil fuels, coal, oil, gas, the form they take, where they come from, how they are similar or different, and how the usage of those has changed over time. What electricity is, right? Voltage, current, resistant, how all of that works, and maybe answering some sort of common questions as to how that would relate to everyday use. And finally, renewable or alternative energy sources, where those work, where it comes from, and what we should expect in development moving forward. And we've done it.